I'm just gonna be here. Okay. Assalamu alaikum. Today me and my group will be presenting about message authentication code. My group are Sarah, Fahmi, Musab, and me, Abdulaziz. So first of all, I would like to talk about the MAC, or what is MAC. So message authentication code, also referred to as a tag, is used to authenticate the origin and nature of a message. MACs use authentication cryptography to verify the legitimacy of data sent through a network or transferred from one person to another. In other words, MAC ensure that the message is coming from the correct sender, has not been changed, and that the data transferred over a network or stored in or outside a system is legitimate and doesn't contain harmful code. MACs can be stored on a hardware security model or a device used or a device used to manage sensitive digital keys. So MAC properties, message authentication code provide message integrity and message authentication. With ALEC, generate a MAC and send the message and MACs to Bob. Bob verifies that the message has integrity by calculating the MACs himself. He also authenticates the message because only ALEC could have generated the MAC. So computation resistancy. Even if an attacker knows n x hash pairs, and as we, it will pair the function shows here. It remains computationally invisible to find a valid MACs for message without knowledge of the used key. So the next class and the next slide will be with my colleague Sarah.
Okay. The different attack categories. We have 5 different categories. First, impersonation, substitution, non-text attack, and chosen text attack, and finally the adaptive chosen text attack. For the impersonation, the attacker knows only which MAC is used and tries to generate a valid MAC with the unknown key. He tries to act like a person who owns the key. For the substitution, the attacker knows the MAC value for one message and tries to find a valid MAC for another message. For the non-text attack, the attacker knows for a bunch of text. He has not chosen himself the corresponding MAC values. He tries to generate a new MAC for a new message. For the chosen text attack, the attacker can choose the text himself. For the adaptive chosen text attack, the attacker can choose a text for which he receives a MAC under knowledge of the previous MACs. Okay, the CBC MAC. In cryptography, a cipher block chaining message authentication code is a technique for constructing a message authentication code from a block cipher. The message is encrypted with some block cipher algorithm in CBC mode to create a chain of blocks such that each block depends on the proper encryption of the previous block. Okay, so the HMAC. What is it? It's a hash-based message authentication code can be used to determine whether a message sent over an insecure channel has been tampered with, provided that the sender and receiver share a secret key. The sender computes hash value for the original data and sends both the original data and the HMAC as a single message. The receiver recomputes the hash value on the received message and checks that the computed hash value matches the transmitted hash value. Okay, the next slide for my friend Fahmi. There is no voice.
Hey, Fahmi.
Okay, thank you, Sarah. I was with sound. MAC and non-repudiation. Non-repudiation is the assurance that a message or originator cannot deny any previously sent message and commitment or action. A MAC encryption does not provide a non-repudiation service. If the sender and receiver get involved in a dispute over message organization, a MAC cannot provide a proof that a message was indeed sent by the sender. So no third part can compute the MAC. The still sender could deny having sent the message and claim that the receiver forget it, as it is impossible to determine which of the two parties compute the MAC. So we have here the using MAC with encryptions. The first step in the MAC process is the establishment of a secure channel between the receiver and the sender. To encrypt a message, the MAC system uses an algorithm, which uses a symmetric key and the plain text message being sent. The MAC algorithm then generates authentication tags or a fixed length by processing the message. The resulting computation is the message MAC. This MAC is appended to the message and transmitted to the receiver. The receiver computes the MAC using the same algorithm. If the resulting MAC the receiver arrives at equals the one sent by the sender, the message is verified as authentic, legitimate, and non-attempt with. Next slide. So we have here the application of the MAC. So the application of the MAC, we have three applications of the MAC. First of all, the electronic funds transmission, IFTS, which is used in the financial market. And we have the maintenance confidentially, and we have the one-time password, which is the most secure nowadays. So I will pass to my friend Musab.
So now we need to make a comparison between MAC, then encryption, and encryption, then MAC. So for MAC, then encryption, encryption is not guaranteed to provide authentication. So may be able to modify ciphertext to create a new ciphertext. To the example, encryption with K key and M equal 0 encryption prime K and M. So the decryption will be K BC, which equal decryption prime K and C. So now we go for the encryption then MAC. So in encryption schemes guarantees secrecy regardless of what MAC does, strongly secure. MAC provides integrity regardless of what encryption scheme does. just because Mac then encrypt and Mac are secure for some Mac's encryption schemes, they may be secure in some settings. Examples, Mac then encrypt with CTR or CBC encryption. So now we go for the security of Mac. Security of Mac, we basically have three categories. We have first the integrity of the message, then we have the role in providing the confidentiality, and finally we have the digital signature. So for the integrity of the message, Mac ensures that integrity of the message as well as the authentication of the message. As for the role in providing in confidentiality, Mac can also have a role in providing the confidentiality of the message, as the majority of the applications which require confidentiality tend to require data origin authentication. And finally, for the digital signature, which is a comparison basically, Mac tends to be faster than digital signature in this regard, which makes it more efficient in terms of security. Macs differ from digital signature as Mac's value are both generated and verified using the same secret key. And I think that's all for our presentation. Thank you.
Thank you.